In this video, I would like to give a brief glimpse of the Pandas module. We will briefly talk about data parsing and about tabular data, which are very common in data science applications, and take a first look into Pandas. When we work with data, that implies that we interact with said data through multiple activities. We need to load the data if they're given to us to use in files, for example. We have to interpret them in data types so that we can easier organize them and use them in our work. We need to cleanse them, which is a very application-specific task, but really necessary in order to get rid of data that are incomplete, redundant, or rubbish, again, based on the application. We, of course, have to analyze the data and often to visualize it. To load the data and to interpret it are actions often included in the generic umbrella term data parsing that you might have heard. Data parsing can also refer to the loading of data from some online source. We have seen string and non-string data. We have seen data structures with data. Let us now see tabular data. Tabular data refer to data formatted in tables. I am sure most people have a working understanding of the tabular structure, but let me review it here for completion. Tables have two axes, the rows and the columns. Rows are often assigned to the various entries of our application. You may encounter other terms referring to the data stored across the rows in a table, such as items or objects. The columns then often represent the various attributes of the items in the rows. Other terms for attributes you might encounter are characteristics or features. The organization in rows and columns is easy to understand and read. Let us see a small example here. This is a snapshot from a large data set I have used in a recent research project of mine. In this project, the data set given to us consisted of text files containing information about asylum applications from immigrants arriving in a country, particularly in Denmark. After I extracted what information I needed from each of the text files, I stored that in a tabular format, as you can see here, so that I can easier work on the analysis and visualization of my data. Every row of the table corresponds to one asylum application, and then its column represent a feature I extracted from the application. For example, the country of origin, the year the applicant entered Denmark, the gender, their ethnicity if they have children, among other characteristics. So how can one create data in such a structure, and how can we read it if it is in a similar structure through our Python code? Well, we can use Pandas, a very popular tool for data science applications. Pandas contains data structures and data manipulation tools for fast and efficient work with data. It is very suitable for work with tabular data, as we have seen already, and heterogeneous data, that is data of various and varied types. It can be easily used together with other tools in Python, such as the NumPy library, the SciPy tool for scientific and machine learning functionalities, the Pickle tool, which we just saw in an earlier video, and many others. Pandas is not part of the standard installation and therefore needs to be installed. You can install it as we showed at the beginning of our course using the conda install command. Remember to activate conda first from your Anaconda terminal. Then, whenever you need to use it in your code, in your terminal, in your notebook, for example, you need to first import it by simply typing import and pandas. And importing convention is to import pandas as PD, so that whenever we need to use some of its modules, we don't need to constantly type pandas, instead we type PD. This is a convention for importing many modules with a short name, so you simply need to import the module you wish and then type as and the short name you want to use instead of the module's name. A little note about the installation of Pandas here. If you install Pandas through the terminal, the Anaconda terminal, as we have spoken, and for some reason, when you go into Notebook and you try to import it and you receive an error that it is not installed, then you can overcome this problem by installing Pandas explicitly to Notebook through the Notebook terminal. I'll show you where to find it right now. So let's assume you tried to install Pandas through the Anaconda terminal, but then when you tried to import it in your notebook, you received an error. That was a problem I had because of my installation options. So what helped me, it was to go here into the Jupyter Notebook, go to New, but this time I'm not going to open a new notebook. I'm going to open a terminal. So you can open a terminal here as before, and then you can use it in order to install whatever you want. So you can use conda install, for example, pandas. Okay, so now let's go into the notebook and see how one of the uses of pandas for us. So first I need to import pandas. I will do import pandas as PD. And then let's assume that we have the dictionary with the cities, the temperatures per month that we saw in a previous video. I am just typing it here. I saved it in a variable called dictdata. So if I print this, this is how my dictionary looks like. I have keys as cities and then nested dictionaries with temperatures. This is a simple example just to highlight one of the uses of pandas for storing such structures in a file and then reading them back. So I have this dictionary and I want to store it in a file. So I can first of all use pandas to do so. So I can use the command, I first create a variable PD file and I call from PD data frame to say that I want to convert something into a data frame. This is a structure, a particular data structure that Pandas has, and which we will cover extensively when we talk about Pandas in one of the upcoming weeks. So don't worry about understanding it now. And then I'm going to say that I want to create this data structure of Pandas from a dictionary. So I type from dict. And then I need to give some arguments. First of all, I give the argument the dictionary that I want to convert into a data frame and store later on. And then I can give it an orientation. That is, which parts of the dictionary, the keys or the columns, are to be used as rows and columns in the tabular construction, in the table that is going to be created. So if I can specify here orient, for example. There are some options here for orient. If you want the default option, which is columns, you don't need to type it because it's a default option. It means then that the keys of the dictionary are going to be the columns in the resulting data structure, in the resulting table. However, if you use another orientation option, which is the index, then it means that the keys are going to be the rows. So each key of your dictionary is going to be considered as one entry in the table. So I'm going to use this orientation myself. And then I'm going to say that now with this line of code, I have created a pandas data structure data frame from a dictionary. What I want to show you in this video, however, is how can I store it in a CSV file, which looks like an Excel file with a comma separated data. So I can say PD file, which is the file or the structure where the dictionary has been converted into data frame. I want it to be sent or converted into CSV. So I simply type to CSV. And then in a parenthesis, I write the file name where I want this to be stored. So I can say temperatures obit dictionary.csv. And I run this. At this point, remember that if you don't want to make a mistake of where you are storing this particular file, where it's going to be created, you can specify a whole path here, the absolute path of where exactly this file needs to be created. So I have created mine, and when I find and open it, this is how it looks like. So you see it looks like an Excel spreadsheet, and as I said in my orientation, the keys of the dictionary are considered the rows, and then the values have been used as columns, and it has created a nice table here. Now let's assume that we want to read a file, a CSV file that is found in our computer, and we want to read it through CSV through Pandas. So I can create the data file variable, and in there I call from PD, which is the pandas, the read CSV. And in as arguments, I just give the name of the file I want to open. Remember that if it's not in the same file, the same folder as that Notebook by default uses, the working environment, the current working environment of Notebook, you may need to specify the absolute path of where Notebook can find this file. So if I do this and I check data file, what it contains, how does it look like? Look that what I'm getting is a nice table, actually. It's tabular data. So now it can read, because it's the PD pandas that is helping it to read it, into tabular mode. In this video, we are not covering how to construct Pandas structures like the data frames that we just saw and use them. We will cover those and other essentials in an upcoming week, which we have dedicated to Pandas. In this video, I just wish to show you how you can write structures like a dictionary in a Pandas structure and then in a CSV file, and how to read data in your Python code using Pandas that is written in a CSV file. So here in this slide, I have an overview of all the commands, the uses of Pandas that we saw in this video, how to import and short name the module, how to write a dictionary into a CSV file, and how to read a CSV file into a data variable into Python and use it. To recap this video, data parsing is the first step when working with data. We saw what tabular data is, and then we introduced Pandas and saw how to convert a dictionary into Pandas data frame and how to read a CSV file. As I spoke about a recent research project of mine where I produced some tabular data from asylum applications, I would like to leave here the references of some of the papers that have already been published on work that is based on this dataset. Thank you for watching.